Hello, in this video we're going to look into the position of equilibrium, a really important term, particularly if you're looking into answering questions on Le Chatelet principle. So to understand the term position of equilibrium, we need to know that in a reversible reaction, you always have a reactants and you've got products. At equilibrium, you will always have a mixture of reactants and products left at the end. Now, if I look at the reactants, they're on the left-hand side. So I've just used the term LHS, left-hand side, and the products are on the right-hand side. Now, when the reaction is happening, try to imagine an analogy here about an escalator moving up. Think of a person trying to run down the escalator because the escalator is going up. Somebody's trying to run down in the opposite direction. If the person is running in a way that after a while they get quite frustrated because they find that they can't run anymore, they are just stuck at the same point. At this point, what has happened is the number of steps that they're taking down are exactly equal to the number of steps that are going up. At this point, we say that the person stays at the same position. In the same way, when a reversible reaction is happening, the reactants are turning into products. So if this is a start, so imagine your reactants are here and your products are at the finish line. So you have the start of the reaction. When the reaction reaches equilibrium, just like the person reached a point where they stayed in the same position, in the same way, when the reaction achieves equilibrium, your reactants would stay in the same position. Now imagine if the reaction carried, if this person was able to move and reached equilibrium, or when they remained stable, they stayed here. Right? So this is their now position. At this point, they're more towards the finish line. So that means the right-hand side is more predominant. So we can say that the position of equilibrium, if this was a reaction, most of the reactants have turned into product before the equilibrium was established. That means the position of equilibrium now lies to the right-hand side. In that case, you've got more of the products than of the reactants. At this point, you're saying that the equilibrium lies to the right-hand side. That means we've talked about the relative amount. So we're discussing the relative amount of reactants and products. So this is the meaning of position of equilibrium lies to the right-hand side. So it's not necessary that at equilibrium, the amount of reactant and products are always equal. They can be different. If they're different, then there are two scenarios. The products can be more or the products can be less than the amount of reactant. So far we've looked into the scenario where you've got more products than reactants. And that happens because the rate of forward reaction was stronger, and therefore most of the reactants reached the products and before the equilibrium was established. So the position of equilibrium is more to the right-hand side. So if I was to plot a graph to represent this, if I plot here, if this is the amount of the substance versus time. Now at the start of the reaction, the amount of reactants are high. So I'll start my graph from here. And as reaction progresses, they decrease and they might plateau after some time. Now the amount of products initially is 0 because I didn't have any products, let's assume at the start. But as the reaction progresses, more and more products are formed. Now I've got to look, where is the position of equilibrium lying? Position of equilibrium is lying to the right-hand side. That means I have got more of the products. So when I plot the graph, the final finish line of the products would be above the amount of the reactants. So the reactants are finishing here. So when I plot the graph, I'll start from 0 and they would the reactants line is there and the product line has to be above that of the reactant. And the point at which the two lines get parallel, that's the point where equilibrium is established. So if you were asked what time was the equilibrium established, you would draw a line from where the lines have gone parallel, and where it cuts the x-axis, that would tell you the time. So far we've looked into the position of equilibrium lies to the right hand side, and now we're going to look into what happens when the position of equilibrium lies to the left hand side. So if the position of equilibrium lies to the left hand side, let's use the same analogy now. So you've got the reactants at the top, so that is your start. Your products are at the finish line. Let's assume the same situation where you've got somebody trying to run down. Now, if they're aligned to the left-hand side, we know you've got reactants, you've got products. That's your left-hand side of the reaction. Products are on the right-hand side. If the equilibrium lies to the left-hand side, that means you've got more of the reactants. That means when the person was running down, they couldn't run down faster, so they achieved, or they remained in the same position at a step which was closer to the start. At this point, the rate of steps, the number of steps going up, became equal to the number of steps taken by the person to move down. In the same way, when a reaction acquires equilibrium, and when the position of equilibrium, if it is towards the left, it indicates that the rate of forward reaction was not as strong as the rate of backward reaction before the equilibrium was established. So you would have more relative amount of reactants than the products at the end. So if you were to plot a graph here, time again, you've got amount on this axis. As before, we start with more reactants, so we've got more reactants here. As reaction progresses, you've got reactant concentration in that format. Products, we don't, if let's say we didn't start with more products, we start with 0. As the reaction progresses, the amount of products increase, but remember you've got more reactants, therefore the amount of product would be below the amount of reactants. So I'll start from 0 and I'll go up, but I'm not going to cross the reactant line. The product line would be below the reactant. So that's where the products is. Depends on, if this was the graph for that position, I would move the product line further down to indicate that the product is way less than the reactant. As before, where the lines you think became parallel or they became plateaued together at the same time, that is the point where equilibrium is established. So far we've discussed what happens when, what is the meaning of when position of equilibrium lies to the right hand side. Now we've looked into what happens when the position of equilibrium lies to the left hand side. Now, what happens when the position of equilibrium is at the middle? So the scenario is where the escalator is going up. If an athlete is running down, so they would be able to run down quite faster. They might even meet or be here in the middle. So that's their positioning. So if you have a reactant and product, and this is your left hand side, this is your right hand side, if the position of equilibrium is at the center, so at equilibrium, you will have the same amount of reactant and product. That means the push in the right hand side towards the right hand side was the same as the push from towards the left hand side. So the amount of reactant would be exactly equal to the amount of product. So now the lines are joining up because that indicates they are exactly the same, and the point at which they plateau, that's the point at which an equilibrium is established. So it's quite important to understand the term position of equilibrium signifies the relative amount of reactant and product. And you can change the relative amount, you can change the position of equilibrium by using Le Chatelet principle. So Le Chatelet principle is all about certain factors that you can use to change the position of equilibrium, because according to Le Chatelet principle, if you change some conditions, then the reaction's position of equilibrium would move to counteract the change. So the position of equilibrium would either move to the left or the right hand side of the equation. The conditions that you can use are either concentration or pressure or temperature. Catalyst will not change the position of equilibrium because the catalyst would just speed up the rate of reaction. And when it speeds up the rate of reaction, it will speed up the rate of forward as well as the reverse reaction. So catalyst will not change the position of equilibrium. It will just establish the equilibrium faster. So in the next video, I will explain how you can use the different conditions to change the position of equilibrium. So thank you for listening and watching, and I hope you've understood the meaning of the term position of equilibrium. Thank you for watching.